Hello everyone, welcome back to the HSE Coach. If you are preparing for a safety officer or HSE officer interview in 2026, then this video is exactly what you need. In this mega interview guide, we have combined the most important HSE interview questions and answers from three major areas: construction projects, live shutdown activities, and oil and gas industries. Whether you are a fresher looking for your first safety job or an experienced professional preparing for your next opportunity, these questions are based on real interviews, site conditions, and recruiter expectations. Watch this video till the end, understand the logic behind each answer, and learn how to explain your knowledge confidently during interviews. So, without wasting any time, let's start with the top HSE interview questions and answers. Let's dive in. Question: what is the role of an HSE officer in the oil and gas industry? Answer: so, what exactly does an HSE officer do in oil and gas? Well, their main mission is to keep people safe and protect the environment. They are the ones making sure everyone goes home unharmed and operations don't harm the planet. Here's how they do it. First, they conduct risk assessments, hunting down hazards before they cause trouble. Think leaky pipes, faulty equipment, or unsafe work practices. Next, they implement safety policies, turning rules into real world actions. No shortcuts, no excuses. They also organize training and drills because knowing what to do in an emergency saves lives. Fire drills, spill response, you name it, they train for it. Then there's the daily grind, monitoring work sites, checking PPE compliance. Yes, that means hard hats, gloves, and goggles are non negotiable. When accidents happen, they investigate thoroughly, not to blame, but to fix what went wrong. How do we stop it next time? And behind it all, strict compliance with OSHA, EPA, and other standards. Because in this industry, safety isn't just policy, it's the law. Question: what are the major hazards in the oil and gas industry? Answer: first up, fire and explosions. We're dealing with flammable gases and liquids here. One spark near a leak, and boom, disaster. That's why hard work permits and gas detectors are absolutely critical. Then there's chemical exposure. Imagine invisible killers like hydrogen sulfide, H2S, just a few breaths can be deadly. Or benzene. Long-term exposure, cancer risk. Proper respirators and gas monitors are optional. They're lifesavers. Confined spaces, these are silent death traps. Oxygen drops, toxic gases build up, you could pass out before you even realize something's wrong. That's why we never enter without testing the air and having a standby rescue team. High pressure systems are another nightmare. Equipment fails, pipes burst, that's how blowouts happen. Regular inspections and pressure relief systems are the only thing standing between routine work and catastrophe. And don't overlook the simple stuff. Slips, trips, and falls kill more workers than you think. Oil-covered platforms, uneven surfaces, one wrong step and you're in the water. Non-slip boots and guardrails matter. Ergonomic hazards creep up on you too. Lifting heavy equipment wrong, your back's done. Repetitive motions? Hello, lifelong pain. Proper techniques and equipment adjustments make all the difference. Finally, environmental pollution, oil spills, gas flaring. This isn't just about fines. It's about destroying ecosystems and communities. Containment plans and leak detection systems aren't just regulatory checkboxes. They are a responsibility to the planet. Question: how do you conduct a risk assessment? Answer: first up, hazard identification. This is where we put on our detective hats. We're looking for anything that could cause harm, chemicals that might leak, machinery that could pinch or crush, even biological hazards in some cases. Walk the site, talk to workers, review equipment manuals, leave no stone unturned. Now we move to risk evaluation. For each hazard we found, we need to ask two crucial questions. How likely is this to happen? And if it does happen, how bad could it be? We're not just guessing here, we use data from past incidents, manufacturer specs, and worker experience. Time for control measures. This is where we put our safety plan into action. Remember the hierarchy? First choice is always elimination. Can we remove the hazard completely? If not, can we substitute with something safer? Then engineering controls, guards, barriers, ventilation. After that, administrative controls like training and warning signs. And finally, PPE, our last line of defense. Don't forget documentation and review. This isn't just paperwork. We record every finding, every decision, because tomorrow's team needs to know why we made these safety choices. And we schedule regular reviews because conditions change. New equipment arrives, processes get updated, and our risk assessment needs to keep pace. Remember, team, a good risk assessment isn't just a formality, it's what stands between your crew and disaster. Do it thoroughly, do it regularly, and most importantly, take action on what you find. Question: what is a permit to work system? Answer: a permit to work isn't just paperwork, it's your lifeline when dealing with high risk activities like hot work, confined space entry, or electrical work. Think of it as an official green light that says, yes, we've made this as safe as possible. Here's what a proper PTW system guarantees. First, all hazards are identified and controlled before work begins. No surprises, no, we'll figure it out as we go. Every risk is accounted for upfront. Second, and this is crucial, only trained, authorized personnel perform the work. No exceptions. If you're not qualified and on the permit, you don't touch it. Third, emergency procedures must be in place and understood by everyone involved, because when seconds count, you can't be searching for the emergency plan. Finally, the PTW ensures crystal clear communication between all teams, operations, maintenance, contractors. Everyone's literally on the same page about what's happening, when, and how. Remember, in high-risk environments, your permit to work isn't bureaucracy, it's what keeps your people alive. Never bypass it, never take shortcuts, and always respect the process. Question: what is H2S and how do you protect workers from it? Answer: imagine this, you're on an oil rig and suddenly you smell rotten eggs. That's hydrogen sulfide, H2S. But here's the terrifying part. At high concentrations, it stops smelling, and just a few breaths can knock you out permanently. Hydrogen sulfide, or H2S, is a deadly gas found in oil and gas hops. It's flammable, heavier than air, and attacks your nervous system. No warnings, no second chances. So how do we fight back? Here's your survival toolkit. 1. Gas detectors and alarms. Your first line of defense. If it beeps, move. 2. Ventilation. In confined spaces, stale air equals death. Force fresh air in. 3. SCBA gear. For emergencies, this is your oxygen lifeline. Never enter an H2S zone without it. 4. Training drills, because panic kills. No evacuation routes, buddy systems, and never play hero. H2S doesn't forgive mistakes. Protect your team, detect, ventilate, equip, and remember, safety isn't just policy. It's what keeps your crew alive. Question: what is the difference between LEL and UEL? Answer: LEL stands for Lower Explosive Limit. This is the minimum concentration of gas in air needed to ignite. Below this level, the mixture is too lean to burn. UEL is the upper explosive limit. This is the maximum gas concentration where combustion can still occur. Above this, the mixture becomes too rich to ignite. And let's take methane, the main component of natural gas. Its LEL is 5%, meaning if there's less than 5% methane in the air, no explosion risk. Its UEL is 15%. Above that concentration, again, no explosion. Between 5% and 15% methane in air, that's the danger zone where ignition could cause an explosion. This is why gas detectors are so critical. They alert us when concentrations approach the LEL, giving us time to ventilate or evacuate before reaching explosive ranges. Remember, these numbers vary by gas. Hydrogen, propane, gasoline vapors all have different explosive ranges. Always check the specific LEL and UEL for whatever substance you are working with. Question: how do you ensure fire safety in an oil refinery? Answer: 1. Fire prevention. First, stop fires before they start. Control every possible ignition source. That means strict hot work permits for welding or grinding. Enforce no smoking zones, yet even that quick cigarette can ignite vapors. And eliminate static electricity risks. Proper grounding is non-negotiable. 2. Detection and alarm systems. Early warning saves lives. Smoke detectors, gas monitors, they are your first line of defense. If there's a leak or a spark, these systems scream danger before flames even appear. And when they go off, react immediately. Every second counts. Pre-firefighting equipment. When fire strikes, you need to fight back fast. Fire extinguishers placed everywhere, inspected monthly. Sprinkler systems tested and ready to drown flames in seconds. And for oil fires, foam systems. Because water alone can make it worse. Know your tools, train your team, or pay the price. 4. Emergency drills. Panic kills. That's why regular fire drills are mandatory. Practice evacuations until they are muscle memory. 2 minutes to reach assembly points, no exceptions. Because in a real fire, chaos means casualties. Fire safety isn't luck, it's layers of prevention, detection, and readiness. Do it right, and everyone goes home. Question: what is the difference between a flash point and auto ignition temperature? Answer: first flash point. Imagine you're heating diesel fuel. That magic temperature where it starts giving off just enough vapor to flash briefly when exposed to a spark or flame, that's its flash point. Key things to remember: it needs an ignition source, and the fire won't sustain itself, just a quick flash and it's gone. Now, auto ignition temperature is completely different. This is when a material gets so hot it spontaneously combusts. No spark, no flame needed. Picture an overheated engine component igniting oil that's dripped onto it. Scary stuff. Here's why this matters in the field. When storing flammables, you worry about flash point for safe handling. But for hard work or equipment design, auto ignition temperature becomes your critical safety parameter. Question: how do you manage contractor safety in oil and gas projects? Answer: first, pre-qualification. You wouldn't hire a driver without checking their license, right? Same logic applies. Before any contractor steps foot on site, we vet their safety records, training certifications, and past performance. No shortcuts, no exceptions. Next up, site-specific safety induction. Every oil rig, refinery, or pipeline has its own dangers. Contractors get a crash course on exactly what they're facing. H2S zones, confined spaces, high voltage areas. Knowledge isn't just power here, it's prevention. Now, the golden rules: permit to work, PTW, and job safety analysis, JSA. No hot work, no confined space entry, no high risk activity happens without these. They force us to stop, think, and plan, because winging it gets people killed. But paperwork isn't enough. We verify with surprise audits and inspections. Are guards in place, gas detectors working, PPE actually being worn? Trust, but always verify. And when things go wrong, full transparency. Every near miss or incident gets reported, dissected, and turned into a lesson. Blame games, zero tolerance. The goal: never repeat the same mistake twice. Question: how do you conduct an incident investigation? Answer: when an incident occurs, a proper investigation isn't just about paperwork, it's about preventing the next accident. Here's how we do it right. First, secure the scene immediately. This is priority number 1. We make the area safe to prevent secondary incidents, preserve evidence, and protect our team. Next, gather evidence like a crime scene investigator. We take time-stamped photos, collect equipment logs, and most importantly, interview witnesses while memories are fresh. Every detail matters. Now comes the detective work. Root cause analysis. We use tools like the 5 whys to drill down past symptoms to the real causes. Was it equipment failure, training gaps, procedures not followed? The fishbone diagram helps visualize all contributing factors. With the why uncovered, we recommend corrective actions, not just quick fixes. We implement systemic solutions. Better training, equipment redesign, procedure updates. We target the root causes we identified. We then report findings to management with clear, actionable recommendations. No sugarcoating, just facts, analysis, and solutions. The real test: implementing lessons learned. We update training programs, modify procedures, and share findings across all sites, because if one location had this incident, others might be at risk too. Remember, thorough investigations with regular follow-up audits are how we stop repeat incidents. This isn't about blame, it's about building a safer workplace for everyone. So the first question is, what is the role of an HSE officer on a construction site? So the answer of this question is, an HSE officer plays a vital role in keeping construction sites safe. Their main responsibility is to ensure everyone goes home safely at the end of the day. This includes implementing health and safety policies on site, conducting toolbox talks and safety inductions so workers know the hazards before starting their job, monitoring compliance with legal and client safety standards, investigating accidents, finding the root causes, and suggesting preventive measures. Ensuring all workers are using the correct PPE and following safe work procedures. In short, an HSE officer acts as a bridge between management and workers to create a safe and productive work environment. Now, the second question is, what are the most common hazards on a construction site? Here's how you should answer this. Construction sites are full of hazards, and identifying them is the first step in preventing accidents. Common hazards include working at height. Falls are the leading cause of fatalities. Scaffolding collapses due to improper installation. Excavation cave-ins which can trap workers. Electrical hazards like shocks, burns, and fires. Heavy machinery accidents, especially with cranes, forklifts, and hydras. Manual material handling injuries such as back strains. Slips, trips, and falls from poor housekeeping. Fire and explosion hazards in high-risk areas. During interviews, you can also add that as an HSE officer, your job is to identify, control, and eliminate these hazards before they cause harm. The third question is, what is a permit to work system and why is it important? So the answer of this question is, a permit to work system or PTW is a formal safety procedure that ensures high-risk jobs are carried out safely. Examples of activities requiring a PTW include hot work such as welding or cutting, confined space entry like tanks or manholes, electrical isolation or maintenance, excavation and drenching, working at height. The PTW process makes sure that hazards are identified in advance, proper control measures are in place. Only authorized and trained personnel carry out the work. By explaining it this way, you demonstrate technical knowledge and practical understanding. The fourth question is, what is a toolbox talk and why is it important? Here's how you can answer this. A toolbox talk is a short safety briefing conducted before work begins, usually lasting 10 to 15 minutes. Its purpose is to discuss the day's specific hazards, reinforce safe work practices, give workers a chance to ask questions or raise safety concerns. For example, if today's activity involves scaffolding work, your toolbox talk should focus on scaffold safety, PPE, and fall prevention. This shows the interviewer you understand site-specific hazard communication. Now, the fifth question is, how do you ensure workers comply with PPE requirements? So the answer of this question is, PPE compliance is one of the biggest challenges on construction sites. You can ensure it by providing proper PPE to workers like helmets, safety shoes, gloves, harnesses, etc., conducting training to explain why PPE is essential, placing PPE signage at strategic locations as reminders, inspecting workers regularly, and correcting violations immediately. Leading by example, if supervisors wear PPE, workers are more likely to follow. Remember, PPE should always be the last line of defense, not the first. The sixth question is, what are the steps in conducting a job safety analysis? JSA. Here's how you should answer this. A JSA breaks down a job into smaller steps to identify hazards and plan controls before starting work. Select the job or task. Break the job into individual steps. Identify hazards in each step. Decide on appropriate control measures. Assign responsibilities and monitor implementation. Example, if you are conducting a JSA for scaffolding, you would analyze erection, use, and dismantling separately, identifying hazards and controls for each phase. The seventh question is, what is the difference between a near miss and an accident? So, the answer of this question is accident, an incident that results in injury, property damage, or financial loss. Near miss, an unplanned event that did not cause harm but had the potential to cause injury or damage. For example, if a worker slips but doesn't fall, it's a near miss. If they fall and break their arm, it becomes an accident. Interviewers often ask this to see if you understand reporting culture. The eighth question is, what is a risk assessment and why is it important? Here's how you should answer this. Risk assessment is the process of identifying hazards, evaluating risks, and implementing control measures. Its importance is huge because it prevents accidents before they happen, ensures compliance with OSHA, ISO, and client safety standards, improves worker confidence and productivity. You can also mention the 5x5 risk matrix approach if you want to show technical expertise. Now, the ninth question is, what types of fire extinguishers are used on construction sites? So, the answer of this question is, fire extinguishers are classified based on the type of fire they are designed to control. On construction sites, we generally use four main types. First is water type extinguisher, color code the red, best used for fires involving wood, paper, or fabric now. Second is foam type extinguisher, color code the cream, best used for flammable liquids like petrol and diesel. Third is CO2 type extinguisher, color code the black, best used for electrical fires, control panels, server rooms. And fourth is dry powder type extinguisher, color code blue, best used for chemical, gas, and mixed fires. For example, if there's an electrical fire at a welding station, using a CO2 extinguisher is safest, while water should never be used because it conducts electricity. This shows the interviewer that you know when and how to use the right extinguisher. The 10th question is, how do you manage scaffolding safety on site? Here's how you should answer this. Scaffolding is one of the highest risk areas in construction, so safety is critical. Use only certified scaffolding materials. Ensure scaffolds are erected and dismantled only by competent personnel. Provide guardrails, toe boards, and stable working platforms. Inspect scaffolds before each shift. Use a tagging system, green for safe, red for unsafe. Train workers on scaffold safety and enforce PPE like safety harnesses. You can also add that periodic inspections during bad weather, like heavy rain or wind, are essential to prevent collapses. The 11th question is, what is lockout and tagout and why is it important? So the answer of this question is, lockout and tagout is a safety procedure used to isolate energy sources during equipment maintenance or repair, preventing accidental startup. Steps include: shut down the equipment properly, lock the energy source using a physical lock, attach a warning tag explaining who locked it and why, test and verify zero energy before starting any work. For example, before repairing an electrical panel, a lockout and tagout procedure ensures no worker accidentally switches on the power, which could lead to fatal electrocution. The 12th question is, what measures do you take to control dust on a construction site? Here's how you can answer this. Dust control is very important, especially during activities like cutting, drilling, and excavation. You can manage it by regular water spraying in dusty areas, using dust separation chemicals where necessary, covering loose material stockpiles with tarpaulins, installing dust collectors for cutting and grinding operations, providing respiratory PPE like masks and respirators, monitoring air quality regularly to stay compliant with site regulations. Controlling dust is not only important for worker health, but also for environmental compliance. The 13th question is, what are the main causes of falls from height? So the answer of this question is, falls from height are one of the leading causes of fatalities in construction. Common causes include incomplete or unstable scaffolding, missing guardrails or handrails on elevated platforms, not wearing or improperly using safety harnesses, using unsafe ladders or placing them incorrectly, poor housekeeping like leaving debris and tools on platforms. If the interviewer wants to dig deeper, you can also talk about fall arrest systems, lifelines, and rescue plans to show your practical knowledge. The 14th question is, what is an emergency response plan, ERP, and why is it important? Here's how you should answer this. An emergency response plan defines what actions to take in case of incidents like fire, gas leaks, structural collapses, or medical emergencies. An effective ERP includes evacuation routes and safe assembly points, emergency contact details for supervisors and authorities, first aid arrangements, and medical response procedures. Coordination with local authorities and hospitals. For example, if a fire breaks out, workers should immediately follow ERP guidelines. move to designated muster points, and await further instructions. The 15th question is, what is the difference between ISO 45001 and OSHA? So the answer of this question is, both ISO 45001 and OSHA focus on workplace safety but differ in their scope and application. ISO 45001, an international standard for occupational health and safety management systems, it focuses on continuous improvement and risk-based thinking. OSHA, a US regulatory body that sets and enforces workplace safety rules. In short, ISO provides guidelines while OSHA enforces legal compliance. The 16th question is, how do you investigate an accident on site? Here's how you should answer this. Accident investigation is about finding the root cause, not just blaming people. Steps include secure the area to prevent further harm, collect evidence, photos, and witness statements. Use tools like the 5 Whys or fishbone diagram to identify the root cause. Recommend corrective and preventive actions. Prepare a detailed investigation report for management and authorities. Make sure you emphasize prevention. Employers love candidates who focus on avoiding recurrence. The 17th question is, what is a confined space and what precautions are required? So the answer of this question is, a confined space is any area with limited entry and poor ventilation, such as tanks, tunnels, silos, and manholes. Precautions include, always obtain a confined space entry permit, test oxygen levels, and check for toxic or flammable gases using detectors. Ensure ventilation is provided where needed. Use SCBA sets if oxygen levels are unsafe. Keep a trained standby person outside for rescue support. Confined space work is high risk, so preparation and supervision are critical. The 18th question is, how do you manage heavy equipment safety? Here's how you should answer this. Heavy equipment like cranes, hydras, and forklifts cause many accidents if not managed properly. You should conduct pre-use inspections for brakes, hydraulics, and load indicators. Allow only certified operators to handle machines. Use taglines, signalmen, and spotters to guide lifts. Define exclusion zones where only authorized people are allowed. Avoid exceeding safe load limits. Perform regular maintenance as per manufacturer guidelines. Adding real-life examples from your own experience can make your answer more convincing. The 19th question is, what is the role of a safety induction program? So the answer of this question is, a safety induction is conducted for new workers before they enter the site. It helps them understand site-specific rules and hazards, learn about PPE requirements, get familiar with emergency procedures, know where first aid stations and muster points are located. A good induction reduces accidents and makes sure everyone speaks the same safety language. The 20th question is, what are safety signages and why are they important? Here's how you can answer this. Safety signages are visual safety instructions that alert workers about potential hazards or mandatory actions. Types of safety signs. 1. Prohibition signs. Red. Example, no entry, no smoking. 2. Warning signs. Yellow. Example, high voltage area. 3. Mandatory signs. Blue. Example, wear safety helmet. 4. Emergency signs. Green. Example, first aid station. These signs communicate safety instantly, especially when workers speak different languages. Now the 21st question is, how do you manage electrical safety on a construction site? So the answer of this question is, electrical safety is extremely important on construction sites because electrical shocks and fires are common hazards. You can manage it by using certified and tested electrical equipment only, ensuring all power tools and extension cords are regularly inspected, installing RCCBs or ELCBs to prevent shocks in case of current leakage, keeping electrical cables elevated, protected, or covered to avoid tripping hazards and water contact, displaying danger high voltage signages at critical points, training workers on basic electrical safety and emergency response procedures. For example, if you are working near water, you must use waterproof sockets and ensure all connections are properly grounded. The 22nd question is, what is a safety audit and why is it necessary? Here's how you should answer this. A safety audit is a systematic process used to evaluate the health and safety performance of a workplace. Its purpose is to Check compliance with legal, client, and company safety standards. Identify unsafe acts and unsafe conditions. Evaluate the effectiveness of safety programs and training. Recommend corrective and preventive measures. For example, during a scaffold safety audit, you check whether platforms are properly secured, guardrails are installed, workers are using safety harnesses. A well documented audit helps improve site safety and prepares the company for external inspections. The 23rd question is, how do you handle chemical safety on a construction site? So, the answer of this question is, chemical handling requires extra caution because incorrect storage or usage can lead to fires, poisoning, or skin damage. To manage chemical safety, always refer to the Material Safety Data Sheet (MSDS) before handling any chemical. Store chemicals in properly labeled containers with hazard symbols. Keep flammable substances in well-ventilated, designated storage areas. Provide appropriate PPE such as gloves, goggles, and respirators. Install spill kits and emergency IOSH stations nearby. Train workers on handling, transporting, and disposing of chemicals safely. For example, if you are working with paints or solvents, make sure there is proper ventilation and no ignition sources nearby. The 24th question is, what is a heat stress management plan and how do you implement it? Here's how you should answer this. On construction sites, especially in hot regions, heat stress can cause fatigue, dizziness, dehydration, or even heat stroke. A heat stress management plan includes scheduling heavy tasks during cooler hours like early mornings or late evenings, providing shaded rest areas and proper shelter, ensuring workers stay hydrated by drinking water every 20-30 minutes, rotating tasks between workers to limit prolonged exposure, training employees to identify heat illness symptoms in themselves and others. For example, in extreme summer conditions, providing cooling vests and adjusting work shifts can save lives. Now, the 25th question is, what are the steps to conduct a fire drill at a construction site? So, the answer of this question is, fire drills test how prepared workers are during emergencies. The steps are: sound the fire alarm to start the drill. Workers should evacuate calmly using designated emergency exits. Assemble everyone at the muster point or safe assembly area. Conduct a head count to ensure nobody is missing. Review the drill performance and update the emergency response plan if gaps are found. A well-conducted fire drill builds confidence, reduces panic, and prepares workers for real-life emergencies. The 26th question is, how do you handle unsafe acts and unsafe conditions on site? Here is how you should answer this. Unsafe acts and conditions are the root cause of most workplace accidents. You should handle them by identifying and reporting hazards immediately to supervisors. If possible, correct the hazard on the spot, like removing trip hazards or securing loose cables. Stopping work if there is a serious risk until proper controls are in place. Recording unsafe acts and issuing corrective action reports. Providing training to workers involved to prevent future violations. For example, if you notice a worker climbing scaffolding without a harness, stop them immediately. Educate them and enforce compliance. The 27th question is, how do you ensure compliance with local safety regulations and standards? So the answer of this question is, compliance with laws and standards shows professionalism and prevents legal issues. You can ensure it by keeping yourself updated on local regulations, OSHA and ISO 45001 requirements, training supervisors and workers about new compliance rules, conducting internal safety audits to identify gaps early, maintaining proper documentation for inspections and certifications, coordinating with local authorities during audits and site visits, for example, when lifting loads, following IS codes or OSHA load capacity rules, ensures both compliance and safety. The 28th question is, what is a behavior-based safety (BBS) program and why is it important? Here's how you should answer this. A BBS program focuses on changing worker behavior instead of just enforcing rules. It's based on the idea that unsafe acts cause more accidents than unsafe conditions. Key elements include observing workers to identify unsafe behaviors, encouraging positive reinforcement for safe actions, coaching workers instead of punishing them, involving employees in developing safety solutions, For example, instead of scolding a worker for not wearing a helmet, explain why it matters and reward those who follow PPE rules consistently. The 29th question is, what are safety KPIs and can you give examples? So the answer of this question is, safety KPIs or key performance indicators help measure how well a site's safety program is working. Some examples include LTIF, last time injury frequency rate, TRIR, total recordable incident rate, number of toolbox talks conducted each month, near miss reporting rate, percentage of workers completing safety training on time. If you add in your interview that you've used KPIs to reduce incidents, it creates a positive impression. And finally, the 30th question is, why should we hire you as an HSE officer? Here's how you can answer this confidently. I have solid knowledge and hands-on experience in construction safety, including implementing ISO 45001 and OSHA standards. I am skilled in conducting risk assessments, safety audits, accident investigations, and creating a strong safety culture. I believe in a proactive approach, preventing incidents before they happen, and I'm confident that my dedication and technical expertise can help achieve a zero incident workplace on your projects. The first question is, tell me about yourself. And the answer is, thank you for considering me for this interview. My name is Rohan Rai, and I have built solid experience working as an HSE professional in oil and gas shutdown environments. In my previous project, I contributed to achieving 1 million safe man hours, which I consider one of my key professional accomplishments. I've also completed certifications such as NEBOSH, IOSH, and OSHA, which support my technical foundation in safety management. I am confident that my experience and proactive safety approach will add value to your team and operations. The next question is, what is zero energy demonstration? And the answer of this question is, zero energy demonstration means physically proving that no energy remains in the system before maintenance. We do this by attempting a try start, verifying pressure gauges, checking fluid lines, and ensuring there is no stored energy. This eliminates accidental activation risks. The next question is, what is lockout tagout or LOTO? And the answer of this question is, LOTO is the procedure that locks and tags energy sources, such as valves or switches, to ensure that no one can accidentally start machinery or open systems during work. It protects workers performing maintenance or repairs. The next question is, why is isolation important? And the answer of this question is, isolation protects against unexpected energy or hydrocarbon release. It ensures a physical separation between the worker and the hazard, preventing leaks, shocks, pressure bursts, or fluid releases before work begins. The next question is, what is method of statement? And the answer of this question is, a method of statement explains how a job will be done safely, step by step. It includes the procedure, hazards involved, control measures, responsibilities, and emergency precautions. The next question is, who develops GHA or JSA? And the answer of this question is, it is developed jointly by the supervisor, the HSE officer, and the workers actually performing the job. The real-world experience adds practical insight to identifying hazards and controls. The next question is, what are the steps of risk assessment? And the answer of this question is, we identify hazards, determine who might be harmed, evaluate the risk level, implement controls using hierarchy of control, and then review and update as necessary. The next question is, what are the types of hazards? And the answer of this question is, hazards can be physical, chemical, biological, ergonomic, psychological, or mechanical. Each type requires different control strategies to keep people safe. The next question is, what gases are commonly monitored during shutdown? And the answer of this question is, typically we monitor hydrogen sulfide, methane, VOCs, oxygen levels, and carbon monoxide. These indicate toxic exposure risks and fire or explosion potential. The next question is, how do you handle H2S risk? And the answer of this question is, we ensure all personnel have gas monitors, SCBA units are ready, workers understand evacuation procedures, and importantly, everyone must move upwind of a leak, not into the gas cloud. The next question is, how do you verify isolation practically? And the answer of this question is, we don't just trust paperwork, we physically verify it. We check valve positions, confirm blinds or spades are installed, perform try-start tests, and confirm zero pressure on gauges. The next question is, what is no harm or no leak? And the answer of this question is, it means work was done safely, no one was injured, and no leaks or environmental releases occurred. It is a standard of safe execution. The next question is, under what conditions can a hot work permit be issued? And the answer of this question is, only when gas testing confirms a safe atmosphere, fire hazards are eliminated, fire watch is assigned, and firefighting equipment is ready and accessible. The next question is, how do you ensure proper gas monitoring? And the answer of this question is, we ensure gas detectors are calibrated, batteries are charged, workers know how to use them, and we monitor gas continuously, not just once. The next question is, what do you do when gas alarms go off? And the answer of this question is, you stop work immediately, raise alarm awareness, evacuate upwind, and wait for the work area to be cleared and declared safe before re-entry. The next question is, how do you ensure PPE compliance? And the answer of this question is, by reinforcing PPE rules, correcting workers respectfully, leading by example, and explaining the purpose of each PPE item, not just ordering it. The next question is, what are the responsibilities of a safety officer? And the answer of this question is, we monitor site activities for hazards, enforce permit systems, perform inspections, provide training, communicate risks, and continuously promote safety culture. The next question is, how do you handle unsafe behavior? And the answer of this question is, I respectfully stop the work, explain why the behavior is unsafe, demonstrate the correct method, and ensure the worker understands before continuing. The next question is, how do you respond during an emergency alarm? And the answer of this question is, we immediately stop work, shut down equipment safely if possible, evacuate to the muster point, ensure everyone is accounted for, and wait for the all clear message. Now the next question is, what is SIMOPS? And the answer of this question is, SIMOPS means simultaneous operations, where multiple jobs happen at the same time. It requires careful coordination to ensure one job doesn't create risk for another. The next question is, how do you encourage near-miss reporting? And the answer of this question is, by removing blame culture, thanking workers for reporting, and showing how near misses help prevent real accidents. Workers should feel safe to speak up. The next question is, what are key safety practices for confined space entry? And the answer of this question is, we perform gas testing, assign a trained attendant, ensure communication, maintain ventilation, and have a ready rescue plan with equipment. The next question is, how do you ensure workers understand the permit? And the answer of this question is, I ask them to explain the permit requirements in their own words, so I can confirm they truly understand the hazards and controls. The next question is, how do you prevent heat stress? And the answer of this question is, we provide hydration, shaded rest areas, frequent breaks, and rotate tasks to limit direct exposure to heat. The next question is, what is breaking containment? And the answer of this question is, it means opening a system such as a line or flange that contains hydrocarbons or fluids. The line must be depressurized, drained, gas tested, and spill control must be ready. The next question is, what is double block and bleed? And the answer of this question is, it uses two closed valves with a vent in between to remove trapped pressure. This ensures no fluid or gas can reach the work point. The next question is, what are the types of isolation? And the answer of this question is, mechanical isolation using blinds or spades, electrical isolation using switch off and lockout, and process isolation for fluid control. All ensure safe working conditions. The next question is, what is permit to work? And the answer of this question is, it's a formal document that authorizes high-risk work. It specifies hazards, required controls, and roles of responsible persons. The next question is, what are examples of hot work activities? And the answer of this question is tasks that generate sparks or heat, such as welding, cutting, and grinding, are hot work and require extra precautions. The next question is, what are examples of cold work? And the answer of this question is tasks like cleaning, fitting, painting, or general mechanical work that don't create ignition sources are considered cold work. The next question is, what is confined space? And the answer of this question is, it is an enclosed or partially enclosed area with limited entry or exit, not meant for continuous worker occupancy, and may contain hazardous gases. The next question is, what are the hazards of confined spaces? And the answer of this question is, common hazards include oxygen deficiency, toxic gas accumulation, limited mobility, and difficulty escaping in emergencies. The next question is, what is job safety analysis? And the answer of this question is, JSA breaks a job into smaller steps, identifies hazards at each step, and defines controls to minimize risks. The next question is, what is a toolbox talk? And the answer of this question is, it's a brief safety discussion held before work begins to refresh awareness of hazards and instructions for the day. The next question is, how do you manage SIMOPS? And the answer of this question is, by coordinating schedule timing, separating incompatible activities, using supervision, and maintaining clear communication among teams. The next question is, what is isolation and what are its types? And the answer of this question is, isolation prevents energy or hazardous material from reaching the work area. It includes mechanical isolation, electrical isolation, process isolation, double block and bleed, and blinding or spading. We always physically verify isolation status. The next question is, what is the frequency of gas testing? And the answer of this question is, gas testing is done before entry, periodically during work, after any break, and continuously if conditions require constant monitoring. The next question is, who authorizes a permit to work? And the answer of this question is, it is issued by the responsible area authority or permit issuer, reviewed by HSE if needed, and accepted by the permit receiver who understands the requirements. The next question is, why is the no smoking policy important? And the answer of this question is, smoking is prohibited in operational areas to prevent ignition sources. Workers may only smoke in designated safe zones, away from hydrocarbons and flammables. The next question is, what are the responsibilities of a fire watch? And the answer of this question is, fire watch personnel monitor hot work, watch for stray sparks, hold firefighting equipment, and stop the job if they detect any hazard. The next question is, what is emergency shutdown? And the answer of this question is, emergency shutdown automatically isolates process systems and cuts energy supplies during emergencies to contain or prevent escalation. The next question is, what is man riding? And the answer of this question is, man riding means lifting a worker using specialized lifting equipment or man basket. This requires competency, pre-inspection, and strict supervision. The next question is, what is work at height? And the answer of this question is, any work performed at a height where a person could fall and be injured, typically above 2 meters, requires fall protection measures. The next question is, what is permit handover? And the answer of this question is, when shifts change, the permit is transferred to ensure the incoming team fully understands ongoing work, hazards, and requirements. The next question is, what is emergency muster? And the answer of this question is, it is the gathering of all personnel at a muster point during emergencies for hit count and instructions. The next question is, how do you stop unsafe work? And the answer of this question is, anyone can exercise stop work authority. If something is unsafe, we stop activity, communicate the risk, correct it, and only resume after making it safe. The next question is, what do safety sign colors mean? And the answer of this question is, red means danger or prohibition, yellow is a warning, blue indicates mandatory instructions, and green shows safe routes or emergency exits. The final question is, why are you suitable for shutdown work? And the answer of this question is, I stay calm under pressure, communicate effectively with workers and supervisors, understand isolation and permit systems, and always put safety first. My experience in shutdown environments makes me confident in maintaining high safety standards. So friends, this brings us to the end of this complete HSE interview preparation video. If you carefully follow these construction, shutdown and oil and gas interview questions, you will feel more confident and well prepared for your next safety officer or HSE officer interview. Remember, interviews are not only about answers, they are about how clearly and confidently you explain safety on site. If this video helped you, please like the video, share it with your friends and colleagues, and subscribe to the HSE Coach for more practical safety training, interview guidance, and career support. Also, don't forget to press the bell icon so you never miss our future videos. Till then, stay safe, keep learning, and I will catch you in the next video.